Thanks for joining me to walk through the notes from section 2.6, some of the most important notes that you are going to take in this entire chapter. This is the basis of where we are headed. We've been working with deductive reasoning with the goal of being able to draw conclusions so that we can ultimately write proofs, and we will get to that. We are building up to it. Right now, our focus is to use deductive reasoning to look at one statement at a time and decide how can we justify and know that it's true. So we've been working on in class using definitions and postulates that we have from chapter 1 to accomplish that goal. Today we're going to add one more to the list, and we are going to be adding properties, and these are actually going to be properties that we have from algebra class that are going to help us to justify how we know a given statement might be true involving equations. Okay, there's one more thing we're going to add to that, theorems. We'll get to that later on. Join me on your note sheet. We're going to again look at properties from algebra. I'm in section 2.6 in your textbook, so you could reference page 136. These properties are all listed there. Okay, they give you pretty abstract examples. I'm going to start by giving you a concrete example of an algebra equation, something that should make a lot of sense, and then I'm going to show you how this might look a little bit different when we start to put it in terms of geometry equations. Okay, so let's start with our addition property of equality. If I have the equation 3x minus 7 equals 16, I can use my addition property of equality to say that I can add 7 to both sides. And if you're looking at that and you were just to go ahead and try to solve it, I guarantee that would be the first step that you're going to do. Why? Because 7's cancel out on the left-hand side, simplifying my equation to a 3x equals 23. I'm going to stop right there. I know I didn't solve it. I'm not worried about solving right now. I'm doing one step in the solving process, and I'm just showing how I can use that addition property of equality. Okay, addition property of equality tells me I can add anything I want as long as I add it to both sides of the equation. The same thing. So, supposing that I have the equation AB equals CD. Just a quick little side note. When you're reading this equation, remember two capital letters next to each other. No segment marking on top refers to the length of the segment AB, or the distance between the two endpoints. So I'm essentially saying that I have the length of a segment AB is equal to the length of another segment CD. I have two lengths that are equal. Okay? If I know that two lengths are equal, then I should be able to add equal quantities to both sides and still have a true equation. So I could take another segment, let's just go with maybe EF, and I could add EF to the length of AB, and I could add the length of EF to the length of CD. Now, if you look at the left-hand side of your equation, you've got AB plus EF. Okay, I know that looks very different than X plus Y, but if we had X plus Y, two different variables, could we combine them? Hopefully you're saying absolutely not. AB plus EF, same thing. I can't combine them, so I'm going to write I have AB plus EF. And then on the right-hand side, well, I've got CD plus EF. Okay, and because of that little step in the middle, I know that if AB is equal to CD, then AB plus EF is going to also be equal to CD plus EF. I have a true equation. Okay, a lot of times we're going to see it without the plus EF that I wrote in red. You're going to see the two equations that I've circled in blue, and you're going to have to figure out what happened. Let's walk through a couple more. So that was the addition property of equality. I'm going to go a little faster through the others now that you have the idea of what I'm doing. Subtraction property of equality. If 4x plus 5 equals 10, then I would be subtracting 5 from both sides, giving me 4x is equal to 5 for my new equation that I know to be true. Likewise, if I have a geometry equation, if AB plus EF equals CD plus EF, hey, that looks familiar. That's what I just ended with up above there. How could I simplify that equation by using my subtraction property of equality? Subtraction property of equality tells me I can subtract anything I want from an equation as long as I do this, subtract the same thing from both sides. So if you're looking at that equation, I see an EF on both sides. If I subtract EF from the left side, it's gone. If I subtract EF from the right side, it's gone. And I'm actually left with a much simpler equation I would then know that AB is equal to CD. Okay, the addition and subtraction are really opposites of each other. Let's take a look at another one. Multiplication property of equality. I know some of you abbreviate these as POS for property of equality. Okay, so we can keep using that if you're used to that abbreviation. MPO, APO, SPO. I've got if x over 2 is equal to 8, or x divided by 2 is equal to 8 is another way of reading that, then what can I say is true? And we should be thinking something like multiply by 2 on both sides. There's my multiplication to get rid of the 2 from the denominator, leaving me with x is equal to 16. So what happens if I'm talking about, this time I'm throwing angles in there instead of segment lengths. I'm talking about angle measures. Okay, remember that little m in front of the angles, just talking about the measure. So if I've got the measure of angle A is equal to 1/2 times the measure of angle B, I still have a 2 in the bottom, same as I just had in the algebra one, so I'm going to multiply by 2 to get the 2's to cancel here, and I'm going to have to multiply by 2 on the left-hand side, because whatever I do to the right, I have to do to the left. That's what my multiplication property of equality tells me. My new equation then is 2 times the measure of angle A is equal to the measure of angle B, the 1/2 canceled out with the times 2. And the right side looks a little bit simpler. And I certainly like the fact that the fraction is gone. Division property of equality. And that's a typo. That should be a D. Change that to a D, please. If 6x is equal to 30, I've got 6 times x. The opposite of multiplying is dividing. So I would be dividing to get x is equal to 30 divided by 6, which is 5. Likewise, if I have 2 times the measure of angle A is equal to 90 degrees, and I want to solve for the measure of angle A because that's my variable, that's my x right there. Looks a little different, but that's my unknown quantity. What am I going to do? I'm going to divide by 2 to get rid of the 2. If I did it to the left, I have to do it to the right-hand side, and I'm left with the measure of angle A is equal to 45 degrees. Those 4 are some of the most basic. We will use those a lot. Addition, subtraction, multiplication, division. Before we go on, I just want to point out that in all 4 of those examples, we did something to both sides of the equation. Okay, I'm divided by 6 on both sides. I multiplied by 2 on both sides. I added to both sides. I subtracted from both sides. That's going to change in a second here. Okay, just notice that we did something to both sides of the equation. Distributive property is probably the one from algebra that you guys are most familiar with and use all the time and use it very well. Okay, so I'm going to run through this one real quick. Multiplying through the parentheses, 2 times 3x giving me 6x, 2 times -5 giving me a -10, of course, equal to 19. I did not change the right-hand side. Notice what I just said. I did not change the right-hand side. I only changed one side of the equation. Okay, can you see that this one would be easy to mix up with multiplication property because I am actually multiplying. I'm multiplying the 2 by both the 3x and the 2 times the -5. Difference is multiplication property of equality, I multiply on both sides of the equation. Distributive property, I only multiply on one side. Doesn't have to be the left side, either the left or the right. Okay, for our geometry example, 2 times the quantity measure of angle A plus measure of angle B is equal to the measure of angle C. I can multiply that through, so I end up with 2 times the measure of angle A plus 2 times the measure of angle B is equal to the measure of angle C. And of course, I didn't change that. The only thing I did is multiply the 2 through, multiply it by both quantities inside the parentheses. Keep that one on there. Combining like terms, this is one of my favorites. It looks so different to you guys with our geometry equations, but it works the exact same as in algebra. If I've got x plus x equals 12, okay, we should be thinking something like I have 1x plus 1x, because there's no number in front there. 1x plus 1x, hopefully you're thinking 1 plus 1. And you're going to say, hey, I actually have 2x is equal to 12. I know I can solve that for x. I'm not worried about that right now. All I'm worried about is this concept of, hey, I can combine those terms. Again, notice that I only changed one side of the equation. I'm abbreviating a little bit there when I'm combining like terms. Okay, essentially I'm adding, right? Different than the addition property of equality where I'm adding to both sides, I'm only adding on one side. If I have AB plus AB is equal to AC for my geometry example, again, we can imagine that there's a 1 in front of there. I have one AB plus another AB, and AB is just my variable. Don't think of it as two separate things. It's one length, and if I put them together, I'm still doing 1 plus 1, and I'm getting 2 times the quantity AB. There's 1, there's 2. Is equal to AC. I didn't change the right-hand side. Substitution property. Things get a little bit more complicated when I get to the substitution property. And the reason is that you're going to be given more information. And the hypothesis of my conditional statement, if I'm used to being given one equation. If I know x plus x equals 12, then I make a new equation. Notice here, if x plus y equals 15 and y equals 10, how can I make a new equation out of this? Well, I'm going to actually take my bigger equation. I don't know that I want to think of it that way, but there's more going on in it. I've got a simple equality statement, and I'm going to save this to do my substitution with. So I'm going to actually take this equation, I'm going to rewrite it, but instead of putting exactly what I have there, I'm going to make a substitution with the equation y equals 10. So instead of x plus y equals 15, instead of writing y, I'm going to go ahead and put in 10 there because I know that y is equal to 10. So my y became a 10 when I rewrote that equation. Okay? Obviously you can see that that would allow me to now solve for x. I eliminated one of the variables from the equation. Same thing if I'm working with angle measures. If the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees, and the measure of angle 2 is equal to the measure of angle 3, again, my first equation is my longer equation here. So I'm going to work with that one. I'm going to rewrite, but I'm going to replace something. So I'm still going to have the measure of angle 1 plus, instead of writing the measure of angle 2, what can I say about the measure of angle 2? The measure of angle 2 is equal to measure of angle 3. So I'm going to write the measure of angle 3 in there. Equal to 90 degrees. Not changing that part. So the only thing I changed is the measure of angle 2 was replaced with the measure of angle 3. Like I said, a little bit more going on there. But certainly something you've seen and you've done. You've just done it more in terms of plugging in numbers. We've got 3 more properties we need to cover. Okay, you have used these, but I'm guessing that these terms are probably not as familiar to you. Okay, but you've definitely used these properties or the concepts that we're talking about. We've got the reflexive property of equality or congruence. Okay, it works the same way. We can just say it with an equals or with a congruence. I'll show you 2 examples to sort that out. Okay, this one is sort of like a duh property. All we're saying here is, you're going to think it's ridiculous that I'm even writing it down. All you're saying, there's not even an if and a then. All we're saying is that if we have a variable, it is equal to itself. So if I have an x in a problem, x is equal to x. It's always the same number, no matter where it is. Okay? Some of you may have run into problems with this in Chapter 1 because you tried to make x something else. Just to give you a number example, if we have an actual number, 4, we can say is equal to itself. Okay, no matter where I have a 4, what 4 I'm working with, 4 is always 4. It has the same value. It doesn't change. For a geometry example. We can say the length of a segment is equal to itself. If we're going to put that in terms of congruence, segment AB is congruent to segment AB. We can do it with angles as well. I want to make one quick note here and point out that AB equal to BA is really the same exact thing as what I've written above it. Switching the order of the letters doesn't change anything because remember, we're looking at these as one variable. That's a variable together. They're not separate variables. Together, they're giving us the length of a segment. Okay, just a common confusion that students have. That's my reflexive property. Again, no if then, one statement. I just gave you a couple examples of them. Any one of those statements is an example. Symmetric property of congruence or equality. Now I do have an if and a then. Okay, a lot of students confuse the two of these. Symmetric property you use at least 50% of the time when you're solving an equation, unless you actually always put the x on the left-hand side of the equation. Okay, most of us like to make the x term positive, myself included. Okay, if that's how you solve an equation and you don't worry about, hey, the x always has to be on the left side, you've probably at some point in your life gotten an equation where your answer was actually 4 equals x. You solved it, you were done, x was by itself, and you have 4 equals x. But I'm pretty sure you didn't write that on your paper. What you wrote instead on your paper is you wrote x equals 4, you circled it, that was your answer. You're right. How do you know it? Whoops. The reason you know it is the symmetric property of equality allows me to switch the two parts and to say if 4 equals x, well then of course x has to equal 4. It's common sense, right? Therefore, in geometry, if I have an equation like AB is equal to CD, but I want it to read CD is equal to AB, I can do that because, again, my symmetric property of equality tells me that I can switch the two parts. Pretty simple, right? Okay, we can write it with congruent symbols. I'm not going to worry about that right now, but that's the only difference here when we're talking congruence. We are on our last property. Save the best for last. This is probably the property that we will use the most in geometry. So if you fell asleep, wake up. It's time to get going. We need to learn this property so that we can use this one. When in doubt, use the transitive property. Okay, let me explain. If x is equal to 7 and y is equal to 7, before I write anything down, think to yourself, there's something that has to be true. Because it just makes sense. We just said x is equal to 7 and y is equal to 7. What can you tell me about x and y? Hopefully you're seeing that x has to equal y because they're both equal to the same quantity of 7. Okay? Some people like to write it this way. I'm going to show you one other way of writing it. They like to say if x equals 7 and 7 equals y, and then you're kind of connecting them with that linking term, the 7, and you're essentially saying, hey, I don't need the 7s. X is equal to y, and you skip right over the 7s, okay? Only if that middle term is the same number or same quantity. Looking at a geometry example. If the measure of angle A equals the measure of angle B, measure of angle B equals measure of angle C, okay, you can think of it one of two ways. You can think of it as the middle term is the same, cross it out, and end up with this conclusion, the measure of angle A has to equal the measure of angle C. If you prefer to write it as measure of angle A is equal to the measure of angle B, and the measure of angle C is equal to the measure of angle B, and you prefer to read it that way, as in, hey, two quantities are both equal to the same quantity, angle B, so we can cancel that out. Angle A has to be equal to angle C. Whatever way you want to look at it, you got to see the beginning is equal to the end. Okay? Like I said, we will use that one a lot. That one can be a little bit more complex than that, but let's keep that simple example for right now. That's it for your properties. I want you to take a minute. If you have any questions about anything that I just went over, write a little note. You have a little spot at the bottom of your paper. Write a little note so you remember to ask in class about it. Just jot a little note down to yourself. And before you're done and put your notes away, I want you to go ahead and write down your last name on the bottom of your paper, but I want you to spell it backwards. Your last name, I want you to spell it backwards. That's going to tell me that you actually did watch my video and you didn't just try to make up answers on your own. So thanks for sticking with me. I know that was sort of a long video, but we had to get through those properties. You guys are going to be super awesome prepared for class tomorrow. I'm looking forward to it.